Actually, I should fire up this computer so I can keep track of the chat. But all right, so hopefully those of you guys who are distant can hear me okay. I'm getting the Twitch chat going so that I can see if you guys have any comments or whatnot. If you're also on the Discord server that's linked on Canvas, you can hop into the MAT112 voice channel, and if you speak, I will be able to hear you. Nobody else will, I mean, unless they're also on the Discord channel. I've got my my microphone muted on the Discord channel because otherwise you'll hear my voice twice, one lagged behind the other. Twitch is lagged by about a second or so from things. So if you start talking, you're probably going to hear me keep talking for a second before I realize that you've got a question. All right, so let me get on to here. Oh, crap. Okay, this is going to be a problem. There we go. There we go. Okay. All right, so let me get onto Twitch and make sure that I can monitor what's going on. So yeah, if you've got a question, then go to the Twitch. Great. And I have to mute the audio in here. Okay, there we go. Just put it in the Twitch chat or in the Discord audio, either way. Camera's probably not going to be all that useful, given that, where are we? Right here. Okay. All right, so I'm going to hop over to Canvas to get us started. So when you get onto Canvas, you'll see your courses. Obviously, there's more here because I've taught a lot and teaching a lot, so MAT112. So let's just kind of go through the, and I'm not sure why this is cut off up there, guys, on the screen. That's annoying. Okay, I'll have to figure out that with tech. All right, let me do this. Okay, so for those of you on the stream, the projector is cutting off some of what's on the screen, so this is gonna look a little awkward until I can come back later and see what the problem is. Okay, so this is Calc 2. Obviously, you've done Calc 1 before. You're going to do more Calc 2. Great. And basically what we'll look at is numerical and symbolic techniques of integration, some applications of integration to kind of physics-y type things. We'll start to do some multiple variable kind of things. So sort of 2 and 3 variable issues. Talk a lot about infinite sequences and series, and Taylor's theorem is sort of part of it. So everybody should have taken Math 110 or 111, or since I think almost all of you are freshmen. Where's Ethan? Oh, okay. You look different. You look much more. Yeah. Yeah. Or you have placement from high school. So hopefully you guys are all in the right spot. So I'm actually going to be co-teaching this course with Dr. Insaldi. So she has the section that's in the afternoon. And what we're going to do is basically, as far as we're concerned, this is one class. It just happens to meet 2 different times. What that means is you guys have 2 professors, not one. I will be the one in the room with you guys at this time every day. But in terms of office stuff or whatever, you can also reach out to Dr. Insaldi. It also means that anybody who's in the afternoon section, you guys have all the exact same assignments, so you guys can work together or whatever. So we did this sort of coordination with Calc 1 last fall, and it was super successful. We had a great time doing it. I think the students really liked it. And obviously with the COVID kind of, us having to be a little bit more careful about meeting people and stuff, it'll be good to have sort of 2 of us instead of just one. The other thing we're going to do that's probably very different than anything you've ever done is, so how does a normal math class work, right? So you do some homework, you take an exam, you get, let's say, an 80% on the exam. you put it in your folder, you feel bad about yourself, you take the next exam, and that 80% is sort of stuck with you forever, right? Well, that's kind of stupid, honestly, because what ultimately is the goal for a class, well, really any class, but a class like a math class, where really all I want is that by December, or November, I guess this year, right? By November, you can do everything, right? So what does it matter if you screw up something in September, as long as you eventually don't screw it up in November, right? That's sort of the idea. So what we're going to use is what's called standards-based grading. So instead of tracking points and blah, 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 like you have to do, um, everything is basically graded pass fail. But and if you fail something or don't do it, then you can redo it later. No problem. Uh, with some caveats, but which the details we'll get into. Um, the one exception to this would obviously be the homework, where you just kind of have to do it. So basically, how this is going to work is um, uh, we have 35 standards. Basically, those are different skills or concepts from the course. And to earn an A, for example, which is what you're all shooting for, right? Uh, you need to master at least 32 of those 35, complete 8 tasks, and we'll talk about what those are later, and then get 95% on the online homework. Now, the online homework is nice because you can resubmit it until, like, each problem you have, um, I think we're going to set up with like 5 or 10 attempts or something like that. So, point being that if you can't get it after 2 or 3 attempts, you probably need to ask a question. And we're also trying to COVID proof this. And we're going to basically mean, well, we have to put deadlines on things, but we're going to set it up so that you can get 100% credit up to 365 days after it's late, which basically means there are no deadlines. So think of the deadlines more as advisory than firm. Um, and then we'll have to have a final, obviously, and so the final will basically make adjustments to what the stuff is from the other thing. So the final is basically, well, at the end of the course, hopefully you've mastered everything. You demonstrate you've mastered everything, and we're great, right? Who cares if you messed it up the first time? So it's very student focused, and it's we're focusing on your learning rather than like picky point accounting and stuff like that. So this is very different than what we did in calculus last semester, and we'll see how it goes. I've tried a variation of this once. It didn't go quite the way I wanted. Dr. Insaldi and I have spent a lot of the summer talking about how to do this, and what are we really after, and what do we really care about, and what's sort of minutia. So hopefully it'll be uh, easy. Now, the way that you demonstrate mastery on a standard, there's 2 ways. Most of the time, what you'll do is we'll have what we're calling fluency assessments. So these are basically um, uh, think of them like a hybrid between an exam and a quiz. It's sort of a written opportunity to demonstrate you can do X. And then we'll have several of these throughout the semester. And what will happen is any standard. So the very first one, you guys will all have the same thing. But like, let's say that you don't demonstrate mastery in those 2 things. When you get to this one, anything you haven't yet demonstrated mastery on, there'll be a problem from it. So you might get 10 times as many problems as you can actually work during a time period, and that's okay, right? What we want you to do is uh, what are you ready to demonstrate that you really can nail now, and leave the rest blank. That's fine. Um, so, um, so that'll be a little weird. The other way that you can demonstrate mastery is basically have an oral exam over something with us, and you can do one of those a week, basically. We'll talk about the details on later. Um, right. So that's pretty much it. There's the rough schedule. The rest of the stuff is on the syllabus. So there's quite a lot of information here, some of which is boilerplate. Um, I'm not going to worry about this today, but keep track of where you're sitting because I'll have to fill out a seating chart. So, I mean, there's only six of you, although I don't know where the sixth is. So if anybody's sort of hard of hearing or vision, make sure you're in a good spot for you, and because then that shall be your anointed spot for the remainder of the semester until the end times. Um, and just in case, I mean, with 5 or 6 of you, it's probably not a big deal, but in case somebody does get COVID, then we'll know who might have been exposed. So, anyway, we all have green check marks from this morning. Yeah, on our little app thing. Did you forget to do it this morning? You did. Don't forget. Um, I don't want to have to be a jerk and start throwing people out of the classroom because I don't have a green check mark or didn't do it. So, anyway. Yeah, so a lot of this stuff that we've put in here in the syllabus, a lot of these things are because of all the COVID stuff that we have to keep track of. Um, Zoom etiquette, more that's going to be relevant for office hours because we're going to try to do most of that stuff remotely just to avoid, too many close contacts. The Discord server is going to be really handy for that. Dr. Insaldi and the other guys will be on there too. If we are meeting on Zoom, can you please put a shirt on and pants too, preferably? You would not believe the stories I've heard from the last semester. Yeah. So, and especially this semester, it is vitally important you guys keep track of your email and Canvas announcements. Because let's say that I get a red X on my app Friday morning, right? Well, I'll just teach from home, and I need to let you guys know that like, hey, you don't have to go to the classroom, get on Twitch, right? But you guys need to be on top of the email, um, both to me and from me. So, um, yeah, attendance, you know, just show up. And obviously, if you're sick, don't, but let me know what's going on, right? Communication is key. Um, and let's see. The way that we're going to do office hours is essentially by appointment only, but you can go to either of us. One of the reasons that we're going to do the appointment only thing is that since some of the times that you guys will want to be talking with us is to do an oral exam, I don't want to have six of you on a call while somebody's doing that, right? Um, my calendar is a little different than hers. Obviously, we've got different teaching schedules. At least for me, just email me and we'll figure it out. Of course, with six of you, that's not too difficult. I think she's going to have like a booking form of some sort, but um, that's not really going to work for me, partly because I've got people that are in very different time zones. And so who knows when I'll be doing office hours. I need to kind of leave myself flexible because all three of my classes, I've got people that are up to 12 hours time difference from here. So it's going to be a lot to keep track of. Which, did you know that, where did I put it? I think it's Nepal is GMT plus 5 hours and 45 minutes. Not 6 hours, not 5 hours, plus 5:45. So yeah, and Pakistan is plus 5:30, and India is plus 5 or something like that. But I was just like, what are these people doing? So anyway, so yeah, there's sort of the list of topics. Let me make sure I hit anything else. Grading scheme, our info, textbook. So we've got, if you want the print one, yeah, it's the yellow one, and make sure it says 4.0. The Calc 1 one is, I think, red. Is that right? Yeah. Um, and we will use a few sections from the Calc 3 one, but you can get PDFs of these for free online at just go to apexcalculus.com. These are open source textbooks, so the people who wrote them have basically aren't trying to make any money out of it. And the printing of it is done by one of those print on demand outfits. So it's super inexpensive, and we just, are trying to save you guys money. We also have our online homework system, which you'll sign up through Canvas. It'll take you to the site, and then I record it if I go back over to Canvas. Where did Canvas go? Here we are. I recorded some instructions yesterday for how to get into it. And yes, I know there's an annoying yellow tint on it. I know what I messed up, and I'll try not to mess that up again. So basically, part one and part two are the explanation. I cut it right in the middle because that's where he was putting in credit card info. And obviously, I'm not going to put all of that up on the internet right? I'm not that stupid. So anyway, so it's pretty straightforward. If anybody doesn't have a credit or debit card, or your financial aid is what's going to pay for books, let me know, because we'll have to do something a little different, but we can handle that on a case-by-case basis. Let's see, textbooks there, all the links are there. Those of you who are remote and tuning in, uh, some guys in my other class said that they couldn't see the Canvas site, um, the ones that were in the distance section. Let me know if you can or cannot see the Canvas site, those of you guys who are remote, and I'll have to look into that with IT, and get that fixed. But you should theoretically be able to see everything that's on the screen now. Later on, maybe next week, we'll talk a little bit more about Mathematica, which is a piece of software we'll use for some stuff. Um, yeah. So your first assignment basically is sign up for Edfinity, like ASAP. And then I put on some Calculus 1 review exercises just to get us ready for the for Friday. So Friday, what we'll do is basically just a couple of problems of, here's some functions, take their derivatives. Here's a couple antiderivative integral type things to do from Calc 1, just to see what you guys still remember, and what we might need to review, and so on. And then on Friday, we'll revisit use substitutions from calculus, and then kind of take that maybe a little further than you guys did in Calc 1. So today, what we want to do is basically, let me just pull up the file. So if you go to the Files tab, one of the things you'll see, it's getting cut off, but it's a folder that says in-class worksheets, and then I've got one that's called Calc 1 Review. So let me download and open this. And we'll talk about this a little. Oops, that is not what I wanted. I wanted to download. Okay, so they've screwed up the download function. That's great. Fortunately, I was the one who wrote this, so well, here, I'll just view it on there. It should be okay. Okay, so let's just kind of review some of our stuff from calculus. Let's go through, and one thing we are going to try is there's a website. Let me just go to it, called Limnu. I think I spelled it correctly. It's an online whiteboard, and so before Friday, if what you guys could do is make a login for this, and then what'll happen is basically I can share a whiteboard, and I can import one of these PDFs, and then we can all scribble on the same thing. With 6 of you, we can also use the chalkboards, but this will be really handy for the remote guys. If you've got an iPad or tablet or something like that, particularly if it's one that has like one of the fancy pens, there's an app version of it, but only for iOS. There isn't an Android app. It'll work in a web browser, though. So there's a million of these whiteboard things, and we've been kind of searching through to find the right one that does the stuff that we want. So we're going to try this one and see how it works. And if it's not doing what we want, we need to try something else, we'll try something else, right? I mean, none of these are perfect. They all have some features you like and some features you don't, and etc. But anyway, for today, we don't have to worry about that. We're just going to kind of look over things together here. Um, and I still need to get the app and set up and stuff on the iPad. But hopefully you remember all of these things from Calc 1. So I've got a bunch of derivatives and a few selected antiderivatives. So what's the derivative of x to the n? Do we remember? Yeah. Yeah, nx to the n minus 1. And then accordingly, what's the integral of x to the n? Okay. Okay, x to the n plus 1 over n plus 1. Now, what's the one problem with that? Well, n can't be negative 1 in that formula, right? Because that would involve a division by 0. But that's where the second line comes in. So what's the derivative of the natural log? 1 over x. And then hence, this here, dx over x, is exactly the x to the minus 1 case. It's just written a little bit differently. So the antiderivative of that would be natural log of x. Well, okay, yes, the plus c. Got to have the plus c. Now, is that correct, or is that there actually something missing? Thank you. Okay. Now, fortunately for you guys, so Dr. Insaldi is not a jerk about the absolute value. I tend to be a jerk about the absolute value, but I won't be a jerk about the absolute value. Yeah, so for technical reasons, when you do the integral of dx over x, it should be natural log of absolute value of x. For most of the time, it doesn't actually matter, but there are some times when it does. Essentially, the reason for that is why is the absolute value there but not over here? Well, what's the domain of the natural logarithm? Yeah, 0 to infinity. So it doesn't include negatives to begin with, and so there's no need for an absolute value. However, what's the domain of 1 over x? Except 0, right? And so because of that, negatives are involved, and so the antiderivative should be able to handle that. Okay, and I hear somebody. Hopefully that's somebody from Discord. Let me go over here. Yes, hey Coy, how you doing? Can you hear me all right? Except 0. Yeah. Okay, so Coy's with us and I can actually hear him. All right, so good. So that's the one exception, right, to the power rule is where the logarithm gets into it. Okay, so then the derivative of e to the x is itself, right? That's one of the really neat things. What's the only other function that has that property that is its own derivative? E to the x is one of them. The other one's far less interesting, but yeah. Yeah, 0, right? Because it's a constant and the derivative of any constant is 0. Okay, well, that's boring, but whatever. And then accordingly, if the derivative is itself, then integral is itself. So the integral of e to the x is just e to the x, and then of course the plus c. Okay, then we've got all the trig functions. So derivative of sine is cosine, derivative of cosine is negative sine, and then the circle continues. And then hence on the antiderivative side, the integral of cosine is sine, and the integral of sine is minus cosine, so don't botch that. Derivative of tangent is secant squared, derivative of secant is secant tangent, derivative of cosecant is negative cosecant cotangent, and the derivative of cotangent is negative cosecant squared, right? And for those of you who are learned math not in the United States. So let me just ask, have you ever heard of tangent before? Or did you just learn it as sine over cosine? Yeah, okay. So I did many years ago. I had a student that was from Poland, and he says, we do not have tangent in Poland. And now what I was imagining was like, due to government corruption and material shortages, they have plenty of sine and cosine in the math books, but they're real short on the tangents, like they are razor blades or something. No, no, it wasn't actually that. Um, yeah, so not everybody actually uses tangent as a thing. Some people just write it as sine over cosine. But yeah. And then the other one that I put on here is arctangent, which what's another way to write that? Yeah, tangent with the -1. The reason I don't like to write that is because when you see tan -1, what do you think? You think tan to the power of -1, which would be 1 over tangent or cotangent, but that's not what we mean there, right? We mean inverse in terms of functions, not inverse in terms of multiplication. So to avoid that ambiguity, I just always write arctangent instead, and then we can't possibly mess it up, okay? And similarly for arcsine and the other guys. The only inverse trig function that I think is worth memorizing in general is arctangent as derivative. The other ones, they come up and you look them up when you need them, and maybe you'll memorize them by osmosis. But yeah, so what is the derivative of arctangent? Do you guys remember? Yeah, that's arcsine as derivative, almost. Uh-huh. Yeah, 1 over quantity, 1 plus x squared. I tend to put it in the other order, but same difference. Um, yeah, so now the good news, right, is that if you forget them, uh, you can either look them up, or if you write y equals arctangent of x, that means tangent of y is equal to x, and then you can do implicit differentiation to figure out what the actual derivative is. So that's how you prove any of these. Um, but yeah. And so accordingly, what's the integral of 1 over 1 plus x squared, arctangent, and then plus c? Okay, good. Now, so those are all the basic rules for pretty much any of the types of functions that we would deal with, right? The power rule takes care of anything that involves square roots, because um, nobody said that the exponent in the power rule had to be an integer, right? It's just that often it is. The logarithm and the exponential, and then of course all the trig functions. That pretty much covers everything that you could possibly want to deal with, except if you have all these basic functions, you can make bigger functions by putting them together, right? So what are the 5 ways that you can algebraically combine two functions? Well, you can add them, you can subtract them. Those are basically the same thing. You can multiply them or divide them. Those are also basically the same thing. Or you could compose them, right? Stick one of them inside the other. And so basically every function, or almost every function, that you could possibly imagine can be written in that form. Some combination of these algebraic things. And so then the question is, well, if I know that a function is built out of two other functions, how does the derivative work? Well, the first one's real easy, right? So what is the derivative of a sum or difference of two functions? And then you add or subtract the answers, right? So the derivative sort of distributes, if you will, over addition. Um, However, that is most certainly not true for products and quotients, right? So what's the Calc 1 trap to say that the derivative of the product is, right? What would be the wrong answer to write here? Yeah, so the derivative of a product is not f prime times g prime. Um, oh, wouldn't it be a lot easier if that were true? But c'est la vie, it is not. Right, so we have to do the product rule, right, which is f prime times g plus g prime times f. And for the product rule, it doesn't matter what order you write things in because it's a plus in the middle, and so who cares? Where it does matter, though, if you botch the order, is the quotient rule, which is a variation of the product rule, right? So if I've got f over g, then the derivative of it is g times f prime minus f times g prime all over g squared, right? Okay. And if you mess up the order in the numerator, then you'll have, because it's a minus, negative of the correct answer. Yeah. Okay, and then last but not least, because this is the one that probably really drives people nuts, is the chain rule, um, which there's a couple different ways you can write it. Um, so let me just write it up here on the board, and hopefully let's see, I'm trying to get where the computer, sorry, I'm trying to get to where the webcam can see. Okay, so f of g of x derivative is the first function's derivative with the inside function plugged in times the derivative of the inside function. Okay, so yeah, so that's the chain rule, and I've written it here in sort of the right hand side is sort of mostly Newtonian style with the prime. The ddx version is the Leibniz style notation. Which one invented calculus? Yes, exactly. Or discovered calculus, maybe is another way. It depends on whether or not you're a Platonist when it comes to mathematics. Yeah, anyway. Okay, so why don't we actually work some problems, and hopefully by next time or next week, I'll have this whole whiteboard thing figured out so that we can actually write stuff up together. So I picked this PDF, by the way, the blank one is in Canvas in the file section, and we're going to have one of these basically almost every day. And as we write them, we'll put them into the Canvas files so that you guys can access them anytime. All right, so let's just maybe work some of these out. So um, we'll just grab some scratch paper if you've got some, and try all three of these, and then we'll chat real quick. And those of you who are online, do the same thing. Just kind of write down these three problems that we've got here, and kind of go through them. Um, just to remind ourselves that we can still do calculus, hopefully. And I hope we didn't just lose the stream. Corey, you still with us there, bro? Oh, that's lovely. Chrome crashed on the desktop here. Oh man, it hard crashed. Okay, well, nope, we're still live. So sorry for the inception there with Twitchception. Okay, yeah, Coy, the delay is a lot worse than I remember it being last year. It sounds like it's almost like 5 seconds. So that may be mildly annoying, but we'll just have to deal with it. Of course, you are literally halfway around the world, so c'est la vie. Okay, so just kind of let me know when you guys have what you think are hopefully the answers. And I'm going to actually switch over to a whiteboard. Okay. So I'm going to switch over my input source to my iPad, and so we can write on that. Let's see, iPad. There we go. All right, so our first function was, oops, it was e to the, oh, I'm going to have to move this. Okay, is that viewable? Yeah, okay. E to the x secant x, what was the rest of it? Here. And just so we're clear, x to the 1/2 means the same thing as the square root, right? Okay, so what's the derivative here then? F prime is, what do we got to use for the first part? Yeah, the good old product rule, right? So it's the first thing times the derivative of the second. What's the derivative of secant? Thank you. Plus the second thing, which was secant, times the derivative of the first, which is just itself, okay? All right, now, how do I have to do the derivative of 1 over x? How do I first have to think of that? Yeah, exactly. So if I think of this as being, this really equals x to the minus 1, then its derivative would be minus x to the minus 2. And then if we do the same thing for the other term, then we'll have x to the minus half, right? Okay, so great. Then we could leave it like this, or we could maybe try and do a little bit of simplification. In particular, I think people sort of aesthetically don't like negative exponents for some silly reason, but we could always rewrite it as this as minus 1 over x squared and that as minus 2 over root x. Um, we could factor an e to the x secant x out of that first term if we wanted. We don't really have to, but um, like that. But yeah, same thing. Um, now, how many of you guys from high school, your teachers like got all bent out of shape if there was a square root in the denominator? Yeah, I do not know why that is a thing. Who cares if there's a square root in the denominator? What, what makes the numerator more privileged than the denominator, right? It doesn't matter. So yeah, I don't care if there's a square root in the bottom. It doesn't matter, right? We got bigger fish to fry in this sort of this class. Okay, great. So all right, now what about the next one? What was that function? We had g of x equaled, what was it? Oh, I can see here, arctan plus x squared plus 1 over cos x plus 3e squared. All right, so the first one, what's the derivative of arctangent? What did we say earlier? okay? Or x squared plus 1 will, if you want to put the thing in the front instead of the back. That's fine. It doesn't. Thank you. Good, getting you trained. Could be like that episode of, you guys watch The Big Bang Theory at all? Yeah. There's an episode where Sheldon starts using operant conditioning on Penny and rewarding her with chocolates to do the things that he wants. And uh, yeah, anyway. Huh? Oh, yeah, excellent. Oh, I was in his head long before he got here. Yeah, yeah. Well, resistance is futile. All right, what are we going to do for x squared plus 1 over cos x? Quotient rule, right. So we'll have the bottom thing times the derivative of the top thing minus the top thing over the derivative of the bottom thing, times the derivative of the bottom thing, which would be derivative of cosine is minus sine, so I'll put sine x there and then flip this to a plus, same thing, right? All over cos squared x. And you can tell that I've been out of practice writing for 3 months because my handwriting looks terrible. Oh, was it x cubed in the original? No, you are correct. It was x cubed. So that would mean I just wrote it down wrong. Okay, so that should have been x cubed. And then that changes this to 3x squared. Well, okay, except the derivative of cosine is minus sine, so then I just put it there. Either way, just trying to avoid the double negative. Yeah, so, uh, okay, what else? What's the derivative of 3e squared? Well, it's 6e to the first, or is it just 3e squared? Because what's the derivative of e to some stuff? Derivative of e to the x is e to the x, right? Yeah, because e squared is just a number. I'm trying to trick you guys. No. Yeah, e squared is a constant. It happens to have an exponent, but who cares, right? So a calculus 1 student, or maybe a bad calculus 1 student, I would get one of the following answers, either 3e squared or 6e, right? Because that's the rule, right? Well, no, it's a constant. So be on the lookout for constants in disguise. Yeah, so, okay, good, you guys got that. And then what was our final function? H of t was 3e to the t squared minus 5 tan t plus 5 over t squared. Oops, sorry. And I do not know why it's cutting this off. That is really annoying. And I will have to get IT to look at it. All right, so the second two terms don't look too horrible, but the first one, what do we got to do? The chain rule this time, right? So what's it going to be? Like, think of it as 3e to some stuff. What's the derivative of e to some stuff? E to the same stuff, but then I have to multiply by the derivative of the stuff, which in this case is t squared, and the derivative of that is 2t. Okay, are we good, Gucci, on that part? Yeah. Okay. Derivative of tangent is secant squared. And then, like before, how do I have to think of t squared, 5 over t squared? I need to think of it as 5t to the minus 2. And so then this would be minus 10t to the minus 3. Or if we simplify here, like so. Okay, good. So, oops, because I know you guys, none of you were doing calculus all summer, right? You were doing calculus all summer? Oh, oh, yeah. Well, that's okay. I wasn't doing calculus all summer either. So, yeah. So basically, we just need to clean out the cobwebs. You guys have all done this before, but yeah. Okay. What about the antiderivatives, which Chrome has frozen? So let me go back to the PD. Oops, that is not the button I wanted to hit. Let me go back to the thing and just copy these problems down real quick. Um, so we also had, let's see, f of x was 3 cos x plus e to the 2x minus 4 over x. All right, so we'll start there. And let me make sure that we're still streaming the correct material. Yes, okay. Okay, so that's our first function. And this time, instead of doing the derivative, we want to do the antiderivative, find the most general antiderivative that we can. Okay, so two of these terms are going to be pretty easy. What's the antiderivative of cosine? Yeah, negative? Gotcha. Yeah. So the antiderivative is 3 sine x. Okay, the derivative would be negative sine, but we're going the other direction. Okay, good. What about e to the 2x? So what's the antiderivative of e to the x? E to the x, right? What's the antiderivative of e to the 2x? That'd be the derivative. Okay, so what's the derivative of e to the 2x? Exactly. Okay, so the antiderivative is going to be this. Okay, now that, by the way, what we've just done is a u substitution, but it's a very simple one, right? So essentially what we just did was we said let u equal 2x. What's du? 2 dx. And so dx is du over 2, and that's why it's division instead of multiplication. Okay. Another way to think about it would be if I took the derivative of my answer, I should get back to where I started, right? So what would I do if I took the derivative of e to the 2x? Well, I would get 2e to the 2x, but I started with e to the 2x. So the only way to get rid of that 2 would be if there was a half there for it to cancel. Yet a third way to think about it would be, well, if the chain rule for derivatives says to multiply by the derivative of the inside, the chain rule for integrals should say divide by the derivative of the inside. That only works if that derivative is a constant like it is here. Otherwise, you've got to do more rigmarole. But yeah, okay. And then last but not least, the 4 over x is 4 natural log absolute value of x. It's just such a habit. I'm always going to write the absolute value when it needs to be there, although in most cases you can blow it off. So just, yeah. Some people are more sticklers about the absolute value than others. I happen to be a purist, so anyway. And then, of course, we've got the plus c. So this means antiderivatives are not unique, right? They're unique up to the constant. And so if the question is to find an antiderivative, it could be pick any value of c you choose, doesn't matter, including 0. But if it's the most general one, then we usually use c to denote that unknown constant of integration. Okay, good. And then let me switch back over to that, and our other function was secant squared and oops. Oops, dang it. Sorry, you guys don't need to see all my text messages. Um, okay, and it's gotten cut off again. That's mildly annoying. Let me see if I can fix that. Well, here. Let me just write it over to the side. Okay, so I may have to set this up for the streaming a little bit differently, so we don't have this cut off business too. All right, so what's the antiderivative of secant squared? Tangent. And you know, it may seem a little cheesy to remind you, like to keep beating that in your head, but one of the things that's going to happen is as we start talking about other techniques of integration, like integration by parts and trig substitutions, all these fancy techniques, then what invariably will happen, and it will happen to all of you at least once, you will have a problem that involves the integral of secant squared, and you'll be like, oh man, do I have to do this by parts or do I have to do this crazy substitution? And you'll go around for 10 minutes and then it'll hit you. Oh, that's the easy one, right? It's just, oh, hi, Ethan. It's just, yeah. So, okay. Well, we should probably quit here in a moment. What was the rest of it? So we've got, yeah, arctangent for the second term. And then the third term is, right, and that looks terrible. And then, of course, our plus C. Okay, good. So yeah, just wanted to kind of clean out some cobwebs. So just to recap then, I put up a brief a bunch of these sorts of practice type problems on Edfinity. It's due tomorrow night, but really it's not really due. We have to set something, and I don't want to set all the deadlines to be the last day of the semester because then you guys won't keep on top of it. Yeah, so have a peek at those and work some sample problems just to kind of flex your muscles a little bit. And yeah, so I'll quit the stream. And those of you guys who are online, hopefully everything worked okay. And let me know if you're having trouble getting to Canvas. My other class, they had some issues. So I will end the stream here and see you guys on Friday.